a continuation of bisectors and triangles. Today we're going to talk about the incenter. The incenter is where the angle bisectors are concurrent. Equal distance from the sides. Yes. What's concurrent, class? Anybody?
It's when 3 or more lines intersect.
When 3 or more lines intersect. So where these 3 angle bisectors intersect is the incenter. Alright? Yeah, on the whiteboard. Where those 3 meet in the middle there, that's the incenter. Where the angle bisectors are concurrent, equal distance from the sides, and the center of a circle inscribed in the triangle. Doing it right now. When you see these yellow motion picture things down the sides, we're captioning. We live. How you doing? So, draw a triangle. Alright, then you can kind of out of this vertex, you can try to sketch what looks like an angle bisector, right? That looks like it splits that angle in half. Bless you. Out of here, do it again. Okay? And then out of the third vertex, split it. And if that is the same as that, right? And that angle is congruent to that angle, and this angle is congruent to this angle, then these are all angle bisectors, aren't they? And they all are concurrent here. Call it point A, and that's the incenter. The incenter is the same distance from all these sides. It's the same distance from here as it is to here, as it is to here. Always and forever. That's the same as that, which is the same as that. They all intersect at 90. And if you tried to put a A would be the center of a circle that goes or fits exactly inside this triangle. Now, isn't it amazing that in every triangle you can inscribe a circle which will touch each side in exactly one place, and you can circumscribe a circle that'll touch each vertex in exactly one place. Isn't that amazing? I didn't either. It's true for every triangle. There's a circle that'll fit perfectly inside of it, and there's a circle that'll go around it and touch its vertices. I thought so. Any question on where the incenter is? It's where the angle bisectors are concurrent. It's equal distance from the sides of the triangle. Alright? And it's the center of a circle inscribed in the triangle. It's the center of this red circle. Okay? Alright, so look at problem 3 on the top of page 321. Problem 3 says that GE is 2x minus 7. It says that GF is x plus 4. Looking at that diagram to the right, what's the relationship between 2x minus 7 and x plus 4? They're equal to each other, aren't they? And why are they equal to each other? What is G in that diagram? G is the incenter because it's where all the angle bisectors are concurrent, right? So if it's the incenter, it's the same distance from the sides, which means these two pieces are equal to each other. So if you set them equal to each other and you solve for x, you can find out how far that point is from the side. And if you know that, you can find out how far it is from G to D. So right here, you would subtract x first. And x minus 7 would equal 4. And then you would add 7 to each side. X would equal 11. So if x is equal to 11, what's the length of this piece right here? 15. What's the length of this piece? 15. So what's the length of G to D? 15. Okay. Take the two expressions, set them equal to each other, solve for x. Yes?
GC would not be though. Or would it still be?
No, G to C is the angle bisector. G to F, G to E, and G to D are the three pieces that are congruent.
So the ones that are 90 angles.
Yeah, because remember in the last section we talked about how you measured a point, the distance from a point to a line, and we said it's the length of the perpendicular segment. That's why that perpendicular symbol is there. Corey, sit up. Brannigan, wake up, sit up. Is it Corey? Cody. Sit up, please. Take a look at Got It 3 on the same page. Q to N equals 5x plus 36. Q to M, 2x plus 51. What do you know about those two expressions? How do you know they're equal? How do you know Q is the incenter? How do you know that? How do you know that Q is the incenter? What's concurrent? Nothing says that QO and QN are congruent. Looking at that picture, how do you know that Q is the incenter? Didn't hear you? How do you know it's in the middle?
In the middle of the lines.
What lines? Say that again? Do two of the angle bisectors intersect at Q? So isn't Q the incenter? Okay, is that what you said?
Yeah.
Oh, I didn't quite hear that the first time. So 5x plus 36 equals 2x plus 51. And this isn't the pick on Cody day. Cody, right? Yeah. You came from Miss Tyler's class, right? If you were to kind of drift off a little bit in that class and fall asleep, not saying that you were sleeping in here. See, I'm off task and everything, confused, and oh, now I got a mess going on. What happens in there? No, when you were in Miss Tyler's class and you just happened to kind of, does she say anything about it, or oh, what does she say? What's that? Okay. Oh, okay. What do you do next year? Minus 36, good. So 3x is going to equal 15. Divide by 3, and x equals... So if x equals 5, you can go right here. What's 2 times 5? Plus 51. 61. That segment is 61, isn't it? The question is it possible for QP to equal 50? In that diagram, is it possible for Q to P to equal 50? Because we got something that looks like this, right? This, that, there's Q, there's P, and this is N. And we know that this is 61. Is it possible for this? Is it possible for Q to P to equal 50?
No.
And that's 90. Why not?
Because it has to equal 180.
No. Why can't QP equal 50? Thank you. It's the hypotenuse of this right triangle. It's got to be bigger than both of the sides. All right, that can't be 50. Any questions on incenters? Your assignment for today is page 322. 4 through 13. Make sure you check headline. 4 and assignment.
Oh, I'm fine.
Yeah, homework. You know what I was going to say.
Okay.